This presentation will introduce C++ functions. We'll use specialization to develop complex programs one step at a time. First, let's take a look at how we've been doing programs to date. So far, we've placed everything in our program into one large program where all the key steps are between int main void and return 0. So let's review. First, we started off with our libraries. Then we had our main program beginning with int main void and an open squiggly. We had an area of the program where we declared variables. We had an area of the program where we used couts and cins to enter key information into the program. We also had an area of the program where we did calculations or other key programming steps using the information that we had placed in with the cin statement. We also had a portion of the program for our outputs, and we ended our program with return 0 and close squiggly. We will focus for our first function on one step of the program where we calculated the area of a rectangle. Now, before we begin, it may look like we have actually more steps or more work to do using functions than in our previous approach. That's true for these simple programs. However, these simple programs are the easiest ones to demonstrate the key portions or steps in developing a function. So, let's find out how we place area equal length times width into a function instead of this step in the program. As we begin, each function has a prototype, a function call, and a function definition. So let's begin with the prototype. A prototype serves almost like a table of contents to tell the program which functions are going to be called later when the program runs. In our case, we'll place a prototype that looks like this: float find area when we send float length and float width to the function. This will go right after the pound include step in the program. Let's take a look at why we develop the prototype as we do. First, the word float indicates that we will in fact be getting a float value back from the function. In other words, when we find area, we will send a value for area back to the calling program, and it will be of type float. Then we have a name for the procedure or function, in this case find area, because it reflects what it does. I would highly recommend that you always have a slightly different name for your function name than for the variable it returns. The reason for this is simple. I don't want you to be confused with values, which variables hold, versus procedures, which functions are. In this case, find area describes what we're trying to do. Next, we have to send information to the function so it can do its job. In this case, we're sending it length and width, and both of those are float values. So, we'll have the length and width for a rectangle, we'll send it to find area and get a float value back. Note at the end of this prototype we have a semicolon. Now let's take a look at how we call this function when we need it. In our case, area is going to be equal to the value that is returned or that comes back from the function called find area when we send it length and width. So it's like having a little machine out there. Here's the length, here's the width, put it together, send me back the area. This will go in lieu of area equals length times width in our current program. Again, looks a little more complicated, but trust me, as we get complex programs, functions is the way to go. Finally, at the end of the program, we'll place our function definitions. Now, if you note, the very first line of the function, float, find area, float length, float width, is identical to the prototype with one key exception. In this case, because we're going to have squiggly brackets, we don't use the semicolon like we did at the end of the prototype. That will be a common mistake that many of you make, so just be aware of that and try to avoid that as you begin. So in this case, float, find area, when we send it length and width, has an open squiggly. We then declare a variable for area, float, area equals, and then length times width. Now, we don't declare variables for length and width inside the function because, as you'll note, we sent them into the function. Those are called function parameters, and in effect, it's like declaring variables for the function. We did declare one for area so that we didn't have to worry about sending the area variable in since it didn't have a value yet anyway. So, float find area sends in float length and float width. We declare float area, make it equal to length times width, and then we return the value for area by going return area. This goes at the end of the program. When we develop large programs, we will have many functions, and each of these will be separate. One mistake that new students make is oftentimes they'll try to combine functions by placing two functions into one with multiple returns. It just gets confusing. So remember, each function stands on its own. You might find it very useful to have several spaces in between functions so that you can clearly see where each one begins and ends. Remember, all these go at the end of the program. It really doesn't matter what order they're in as long as they are there. Okay, let's take a look at how this would evolve if we did functions instead of our old way of placing everything in the program into the main program area. On the left, we have the area of a rectangle program, much as we have done it all the way through our course so far. On the right, we are doing the same thing, but we're using a function to find the area. Note in blue, I have the prototype after the pound include. Note that in blue, I have the function call where area equals find area when we send it length and width. And then finally, note that we've placed the full function definition at the end of the program, where we have float find area when we send it length and width. We declare area inside the function, make it equal to length times width, and then return that value. Okay, I want this page of the presentation in your notes. After you place this in your notes, get your notebook checked, and then make a program called Rectangle2 and get it to work with the functions as shown on the right. Once you get the find area function in the same program, I want you to add a second function for finding perimeter. It'll have a prototype, a function call, and a function definition. You'll also need to add a variable for perimeter in the main program and a cout statement for perimeter in the main program. Okay, let's get to work and build our first functions.